This video is about graphing linear function. Your learning objective is to graph a linear function. Bear in mind that a linear function, when you graph it, it looks like a straight line. So before we graph them, let's go over the different types of gradient. Your gradient, when your gradient is positive, your line will look like it's going up. Now, when your slope or gradient is negative, then your straight line looks like it's going down. When your gradient is horizontal line, your gradient is 0. And when the line is a vertical line, your gradient is undefined or there's no gradient. Okay, let's start graphing, and we are going to concentrate on these two kinds of line. Okay, or slope or gradient, positive and negative gradient. Okay, the first strategy to graph a linear function is to make a table. Given an equation y is equal to 2x minus 1, look at the format of your equation. It's in the gradient and intercept form. Okay, so you are just going to assign any value to all the x. So I use 0. And I just substitute 0 to x, and if I do 2 times 0, it's 0, it's a negative 1, minus 1 is a negative 1, so the y is negative 1. Okay, so then in the second one, I'm substituting 1 for x, and so here's the equation, and on the third one, I'm substituting 2 to x. Okay, so that means I'm using 3 points, I'm making 3 points here. So the first step is to substitute the value of x into the equation, and then you'll get the answer for the y value, and you can just write it as coordinates or ordered pair, so it's easy to graph. Okay, now I'm going to carry over these values or these coordinates on the next slide. Okay, so here are the values, and now we can graph the equation or the linear function that was given to you. Okay, so we have 0 and negative 1. That's the first point. And then we're going to plot 1 and 1. That's 1 and 1. And the last point is 2, 3. X is 2 and y is 3. And now since we have 3 points, then you just connect the points and extend the line. And this line, you can label it as y is equal to 2x minus 1. For some, they will require you to do at least 5 points, and also that you include negative values for x. Okay. The next strategy or the second strategy is to find the intercepts. There are 2 intercepts. That will be the x-intercept and the y-intercept. So given the equation, again, we're using the gradient and intercept form. So your equation is y is equal to negative 2x plus 6. Now, if you take a look at this, the coefficient of x, which is the m, is negative 2. So that means that your gradient is a negative line. So you can check, it should look like that the line should be going down instead of going up. Okay? So now that we are building our line, okay, so first let's find the x-intercept. If you are solving for the x-intercept, then substitute 0 to y. When we say y, this is your y, okay? And so then solving for x, I substitute that as 0. You have negative 2x plus 6, okay? And so we have that. And what we did was we added 2x on both sides, and then we divided by 2. So then 6 divided by 2 is 3. So the x-intercept is 3, 0. It's actually a point. So you have 2 coordinates. Your x is 3 and the y coordinate is 0 because we already set it to 0. Okay, so we already have 1 point. So here's the x-intercept, 3, 0. This time we're going to find the y-intercept using the same equation. So that means we're going to set x to 0. Okay, so now we are finding y. Y is equal to, and then I substituted 0 for the x. So negative 2 times 0 plus 6. So y is 6. So you have another point. This time, the coordinate is 0, 6. Okay, we now have 2 points. Now we can plot the line. Plot the points and then we can have a straight line. On the next slide, that's what we are doing. Okay, so here's the y-intercept at 0, 6. As you can see, it's touching the y-axis. And then the x-intercept is touching the x-axis, 3, 0. So this line is negative 2x plus 6. The gradient is negative, so your line is going down. Okay, that's the second strategy for graphing a linear function. Here's the third one and the last. Okay, let's graph y is equal to negative 2x plus 2. Let's label what we have here. 2 here is your y-intercept. And then we also know the gradient, which is a negative 2. So that's the gradient. Because this is negative, so the line should be going down. You already have the line here. Okay, so the line is, we know the gradient. Okay, oh sorry, we know the y-intercept. So let's graph or plot the y-intercept. Y-intercept is 2, so we have 2 over here. And now let's take a look at the gradient. If it's negative 2, so that means it's negative 2 over 1. And so 2 is your y, or the vertical line. We talked about this at the gradient video. And then 1 is your x, or the horizontal. So if we follow that one, from your y-intercept, it should, if we are going down from the y-intercept, we need to count 2 units down, 1, 2, and then there should be 1 unit, or x, going to the right. So 1 unit, and that 1 unit is this number. So 2 units down and 1 unit to the right. How do I know that I am going to the right? I know that I'm going to the right because the gradient is negative, so the line should be going downhill. So that I move it to the right. Okay, so that's the second point. We are going to keep doing that for all other points. Okay, so that's the second point. Let's do from the y-intercept, let's go up. So it should be, because here the y is 2, so we go 1, 2 unit up, 2 units up, and then the x, or horizontal, this one, it's 1 unit, so then we go to the left 1 unit. So that should be the next point. Now, because there's no space here anymore, so let's go down here. So again, gradient is 2, so the y should be 2 units. So 1, 2, and then 1 unit to the right. So that's the last. And then you can just connect all these points and you make a straight line for your linear function. This is the third and last strategy for graphing linear function. Now, because the gradient is negative, so the line is decreasing. Okay, that's about it for graphing. Now, let's go back to types of gradient. You have seen the positive gradient, the negative gradient, and then we still have 2 left, which is the horizontal one, and a horizontal line is a 0 gradient, and then the last one, the vertical one, is undefined. Now, I would like you to think about these last two, 0 and undefined, or no gradient. Okay, so the questions are, what if the numerator is 0? And what if the denominator is 0 for your gradient? So your m equals y over x, or y divided by x. Think about it. What if your numerator is 0? And then the other one is, what if the denominator is 0?